Next one is kind of similar to this. If you have I to the power of minus 6, that is the same as 1 over I to the power of plus 6. Remember this rule here, a to the power of minus n is equal to 1 over a to the power of plus n. Okay, so in this case, I to the power of 6, I can go ahead and always divide 4 into that. Let's just do that, even for the smaller exponents like this. So if I go divide 4 into 6, would be 1 times 4 is equal to 4, and the remainder is equal to 2. So what that means really is means 4 times 1 plus 2 is equal to 6. So if I relate that to this exponents here, so I to the power of 6 is equal to I to the power of 4 to the power of 1 times I to the power of 2. So look, this is I to the power of 4 times I to the power of 2, which is equal to I to the power of 6. So I to the power of 4, we established that is equal to 1 always. You're going to remember that. So if I replace that with 1, 1 to the power of 1 would be 1. So again, we get the whole thing would be the same as I to the power of remainder, which is 2 in this case. So whatever remainder would be, that goes here really. So I to the power of 2, we already established what I to the power of 2 is. I to the power of 2 is equal to I times I, which is equal to minus 1. So that would be equal to simply minus 1. So this would be equal to 1 over minus 1, which is equal to minus 1. Again, remember, everything should turn equal to plus or minus 1 or plus minus I. But if I use that little chart I showed you, we started with I squared is equal to minus 1, I could establish that as well. So if I remember you said I squared is equal to minus 1. You know that. We start with that. Now if I go through the pattern here, the next one would be I to the power of 3. Now I to the power of 3 is equal to minus I. So this would be equal to minus I, right? And if I go with the pattern here, the next one would be I to the power of 4. I to the power of 4, we already established, is equal to plus 1. And the next one after that would be I to the power of 5. I to the power of 5. Remember, we established what I to the power of 5 is equal to plus I. Plus I. And if you remember this pattern also, you can quickly find out what would be the next one. So the next one after that would be I to the power of 6. And that's exactly what confirmed by dividing 4 into that. See how I to the power of 6 turns out to be equal to minus 1. And so as here, I to the power of 6 is equal to that. So if I continue with the pattern for the smaller exponents, this would be I to the power of 7, which is equal to minus I to the power of 8 would be equal to plus 1, I to the power of 9 would be equal to plus I, and so on. I to the power of 10, I to the power of 11, I to the power of 12, I to the power of 13, and I can put 3 dots here, and this goes forever. Again, for the larger exponents, we can, or even for the smaller exponents, we can always divide into 4. by knowing that I to the power of 4 is equal to 1, and establish that way. So let me see if there is any questions. Yes, so Arden says, let me open the discussion so everybody can see what everybody is typing. So Arden says, so always divided by 4. The 4 just turns out to be the easiest, as Asti says. So 4 is the easiest to use. If you use if you use a different number, if you choose to use 6, you can divide it into 6, but then you have to make sure that I to the power of 6 would be equal to minus 1. That's not the most convenient one to use. Okay? When you're doing the large exponents, you always divide it into 4 exactly, and then you look at the remainder. But if it's a small exponent, you can use this pattern, I guess, or you can always divide it into 4 if it's small enough. So yeah, if you have very large number like Arden putting there 10,000, same, you just divide 4 into that, and you proceed. So if you have 10,000, divide that into 4, so the remainder would be 0, right? And then the whole thing would be equal to just 1. There's no remainder. So can you imagine there's no remainder here? If there were no remainder here, so that would be just I to the power of 4 to the power of, for 10,000 would be 2,500. So the whole thing would be equal to 1. There's no remainder, so the whole thing would be equal to 1. And also, if you look at this one, the one are equal to 1, all these remainders would be equal to 0. If you notice that, when you divide 4 into 4, the remainder is 0. If you divide 4 into 8, the remainder is 0. So these are all factor of 4s. That's why it turns out to be plus 1.